blockchain. You've definitely heard the term buzzing around. It's tied to cryptocurrency, to billion-dollar startups, and to the future of, well, just about everything. But behind all that hype and, let's be honest, all the confusion, what is it really? How does it actually work? Well, today we're going to pull back the curtain and find out.
You know, Arthur C. Clarke famously said, "Any sufficiently advanced technology is indistinguishable from magic." And that quote really captures the feeling around blockchain. It can absolutely seem like magic. But today we're going to peek behind the curtain. We're going from magic to method.
Because there is a clear, logical method to all of this. And in the next few minutes, we're going to walk through that method step by step to show you exactly how this technology builds a whole new kind of trust in our digital world.
Here's the plan. We'll start by separating blockchain from its famous cousin, Bitcoin. Then we'll dive into the nitty-gritty of the digital ledger itself. After that, we'll see how the whole network creates trust, look at some amazing real-world uses, and finally, take a good, honest look at what the future holds.
Okay, first things first. To really get what blockchain is, we have to get past its most famous application. You know, it's kind of like trying to understand the entire internet by only looking at email. We need to see the bigger picture here.
So what is the actual difference? Well, a blockchain is the technology underneath it all. It's the distributed ledger, that secure database. Cryptocurrency, on the other hand, is just one use for that technology. Think about it like this. Blockchain is the railroad, and cryptocurrency is just one of the many trains that can run on those tracks.
All right, so here's the core idea. A blockchain is a digital ledger, but it's got 3 superpowers. 1, it's tamper-evident, which means you can see if anyone has tried to mess with it. 2, it's tamper-resistant, which makes it incredibly hard to actually change anything. And 3, it's shared by a whole community without a central boss, like a bank. Imagine a shared notebook that everyone can see, everyone has their own copy of, and once you write something in it, it can never be erased. That's the basic idea.
So let's get into the mechanics. How does this ledger actually get built? How do you go from a single piece of information to this secure, almost unbreakable chain? It all starts with the smallest piece of the puzzle, a single transaction.
A transaction is really just a record of something happening. So in this example, Alice wants to send Bob $17. She has $20 from an earlier transaction. The system takes her $20 as an input, and then it creates 2 outputs, one for $17 that goes to Bob, and a second one for $3 that goes right back to Alice's change. The really crucial thing here is that the system doesn't just say Bob got paid. It records the entire flow of value as one single event, accounting for every last dollar.
But these transactions don't just float around on their own. The network gathers up thousands of them, all these recent records, and bundles them all together into a big list. This bundle is what we call a block.
So how does this block get its unique digital seal? Well, it uses a super clever tool called a cryptographic hash. Just think of it like a digital fingerprinting machine. You feed it any data, like all the transactions in our block, and it spits out a unique code. And just look at how powerful this is. Changing the capital W in Hello World to a lowercase one creates a completely different hash. This extreme sensitivity is what makes it so secure.
So how in the world do you create a single fingerprint for thousands of different transactions? You use a really efficient process called a Merkle tree. It sounds complex, but it's not. First, you hash every single transaction by itself. Then you start pairing up those hashes and hashing them together. You just keep repeating that process, pairing and hashing your way up the chain until you are left with just one single final hash. And that hash, the Merkle root, is now a super compact, super secure summary of every transaction in that block.
And here it is. This is where it all clicks into place. This is how the chain is actually formed. Each new block doesn't just hold its own data, it also contains the unique hash, that digital fingerprint of the block that came right before it. This creates this incredibly powerful link. If you try to change a transaction in an old block, its hash will change. That will break the link to the next block, so its hash will change, and on, creating a domino effect all the way down the chain. It becomes completely tamper-evident.
Okay, we've built the chain, but who maintains it? Who gives the thumbs up to new blocks? This is where the decentralized network comes in. The power of the crowd that creates trust without needing a big bank or a central server to call the shots.
And this trust is really built on 3 pillars. First, decentralization. This just means everyone has a copy of the ledger, so there's no single point of failure. Second, transparency. Participants can see the transactions, which keeps everybody honest. And third, immutability.
This means once something is recorded, the past is incredibly hard to change. Put those three things together and you get a system where you don't need to trust a central person or company, you just need to trust the system itself.
So if there's no boss, how does everyone agree on which new block gets added to the chain? Well, they use a process called consensus. It's basically the rule book that everyone on the network agrees to follow to make sure new transactions are valid before they get added to the ledger.
Now, there are a lot of different rulebooks, but the two you'll hear about most are proof of work and proof of stake. With proof of work, which is what Bitcoin uses, computers compete to solve a really hard math problem. The first one to solve it gets to add the next block. With proof of stake, people lock up some of their own cryptocurrency as collateral, and the system chooses validators from that group. They're different methods for sure, but they have the same goal: to make it way too expensive and impractical for anyone to try and cheat the system. Okay, so that's the how. Now for the really important part, the so what. Why are companies investing billions and billions of dollars into this technology? Well, it's because it can solve some very real, very expensive problems.
Let's start with finance. Sending money across borders right now can be a total nightmare. It's slow, it's expensive, because it has to hop between multiple banks and each one takes a cut and adds delays. Blockchain can just cut out all those middlemen. It creates a direct, secure line for payment that can turn a process that takes days into one that takes just a few seconds.
And the impact on cost is just huge. According to research from Deloitte, blockchain could slash remittance fees, that's the cost of sending money, by 40 to 80%. That is a massive saving, especially for the millions of people who rely on sending money back home to their families.
Or think about supply chains. Right now, it's really hard to track a product all the way from the farm to the store shelf. A blockchain provides a shared, single source of truth that everyone involved can see and trust. Walmart, for example, uses it to track produce. So if there's a food safety scare, they can trace the source in seconds instead of days, which can stop more people from getting sick.
And the applications go even further, into things like our personal data. Imagine a secure digital identity that you control, not some company. Or a single secure health record that follows you from doctor to doctor, giving you true ownership over your most sensitive information. It's powerful stuff.
So, is blockchain the solution to everything? Of course not. It's really important to have a realistic, clear-eyed view of the challenges that still exist on the road ahead. For instance, that proof-of-work model we talked about is famous for using a massive amount of electricity. Some networks also struggle with scalability. They can get bogged down when too many people are trying to use them at once, kind of like a highway at rush hour. And that immutability we love, it's a double-edged sword. It provides amazing security, but it also means correcting a simple mistake can be a really complicated process.
But despite the challenges, the fundamental idea here is revolutionary. At its core, blockchain is a technology for creating trust and agreement. It offers us a brand new way to record what is true, in a way that is distributed, secure, and transparent. So the final question to think about is this: what parts of our world, from finance to voting to how we own our own data, are built on old models of trust and are now ready to be rewritten?